you know, thanks for watching my video. I mean, this is one of my biggest projects ever. I'm going to keep going with bigger projects. Hopefully these are successful. I'm going to really test my limits on my editing skills here and my building skills. But I have no idea what I'm doing. So we'll see how this goes. But any suggestions, feel free to leave in the comments. Yeah, let's build something. So the first thing we're going to do is get everything we're going to use in this build. So lay it all out and start organizing. So we have the ATM Mega, we have the crystal oscillator, we have a bunch of parts on this styrofoam little block here. It's very useful to keep them together this way for building. Oops, I made a mistake. These two wires, the blue and yellow, were swapped, so I'm going to flip them. Yellow should be negative, and blue should be positive. If you do that, when you put on the battery, you can see the LED light up. But you haven't actually got the battery cable now, so let's do that next. So just again, yellow is negative, blue is positive. You can test it at this phase by putting on a battery. If it works, that light will turn on, the LED right there, so that's how you know that it's getting power properly. If you hooked it wrong, you'll know because the light won't turn on, or these voltage regulators start overheating, etc. You'll be able to figure it out pretty quick. So yeah, now is a good point to check to see if you're even getting power to the circuit here. Now it's time to program it. Let's get started. So now we're going to show you how to use a Arduino board to program a standalone Arduino. So just chip the let's get it focused a little bit. I'll get that finally turned off. Just chip the AT Mega 328 right here. This is the chip that we used on the standalone. You can buy them way cheaper than you can buy one of these boards. So as long as you have one of these boards lying around, you can get multiple of these chips and program all these boards and use them in your standalone. Saves you a lot of money. So that's why most people do this. I learned it from watching a video, and now I'm doing my own method to show you how to do it for either our class or whoever's watching. But basically, got this board. You take just a screwdriver, whatever. You want to get it under here and just kind of pry up this chip. Because we're going to use this board and we want to switch this chip out of our chip that we have in our standalone, right? So if we take this chip and remove it, set it aside for later, so we can put it back in the board. And now we want to, of course, bring in our standalone here. So here's the standalone we built earlier, right? Looks nice and pretty. You want to keep in mind where this is here. That's the notch that tells you what side has to be up. And up in this case, I mean up facing this button. So now we want to take our screwdriver or whatever tool you have that you can get underneath here and just kind of, actually you could probably use your hand on this one maybe, but pry it up as well gently. You want to not be careful not to bend the legs. So once you have this out of the board, you're going to take it over here. Oh, like got a little bent, see? That's what I'm trying to avoid. These legs get damaged, you can't repair them very easily, by the way. So you want to be real careful with these legs. You want to take it out of the board once there, you want to make sure that the legs look nice and not damaged there. Maybe that one's going to stick in a little bit. Bend them a little bit back and make sure they're nice and uniformish. Not perfect, doesn't have to be perfect for this to work. When you take this, you want to transfer it back to this board. You see this notch right here, by the way? Again, make sure this notch is facing that way, away from this. You can actually look right here, and if you look right there, you see that little notch it's showing? Yeah, you want the notch lined up with that notch that it's showing in the diagram there. So we have to get the chip, and we just kind of pop it in here. And this is something that takes a lot of patience. You have to make sure these legs line up, which I've already pre-bent the legs, so they do. And once you have the legs lined up, you want to gently push it down. So you have it pushed down, you make sure it's in there a decent amount, so it's making good contact. If it's not making good contact, it's not going to work well. And with that, you should have a programmable board. So let's program this thing now. So let's get started on this. This wonderful Arduino board we moved the standalone ATM Mega to an actual programmable Arduino board. So when we put this in here, we hook it up to the computer through old school printer cable basically, and we're going to start programming. We're going to keep this basic, keep this simple and quick. So instead of using our own custom code, which you can do if you know how, we're just going to come over here, hit File, hit Examples. These are built-in examples you should have if you download the Arduino compiler off of Google. But these built-in libraries are pretty useful if you're just starting out on coding. So I'm just going to pick blank file display. Let's make this LED blank. So we hooked the LED to pin 13, which is the built-in for these, by the way. So when you see, like in this code, it says built-in, that means it's picking pin 13. So if we look through this code real fast, it says a bunch of stuff, it has some comments, but basically, the built-in pin 13, which is where we have the LED hooked up right on the standalone board over there, you have it going from low to high, back to low. So low means off more or less, high means on and off. So it's going to basically cause the LED to go on, off, and keep blinking. That's all the code's going to do. If you want to do something else, you can do whatever you want. Like I said, it saves money to build these standalones, but you'd have to code it yourself, right? But this is the easiest way to get to test to see if it's working. So we're just going to upload this. You click this little upload button here. It takes a little bit. Hopefully, I have the right port connected, because I might have that hooked up to. No. Cool. Sometimes if you have the wrong port selected up here. Not here. Here, what says ports? If you have the wrong port selected, it might try to upload the code to your mic or your camera, and that or speaker, whatever else you have hooked up, right, to a USB port, and that's not good. It won't harm anything, and you'll catch it, but you have to pick the right port, is what I'm saying. It defaults normally to whatever one you've used last. So that's pretty much how you upload code. So now that we got that done, let's move this back. Let's get to finishing this project up. Oh boy. So now that we have it nice and programmed, we've built the standalone, we're ready to go. This is a little bit of a longer video, but you know, such is life. That happens every now and then. So we're going to pop this bad baby back out of the board, because this is what we're going to use now. We have it programmed, we have it ready to go. Let's get this back out. Again, be gentle, make sure you don't bend those legs, because those legs are hard to fix if you break them. Got out of the board, great. Set the board aside, you can put the original chip back in if you want, or leave it to be programming other chips in the future, whatever you want. Bring this board back over here. Oh man, look, that leg got bent again. That's not good. This isn't the best way of doing this, by the way. This is just a quick, easy way for beginners. There are better ways of doing this, but I mean, if you're a beginner, this is so much easier, it's so much better, so much faster. It's so much simpler to understand too. So we'll take this chip, pop it back in. Make sure again that notch is facing towards the button, and we pop it back in the board. Make sure the legs line up nice and pretty there. It's kind of easy to line back up because you're just lining back up with respect to that button. You pop it back in like that. Okay, great. And we move the board back here. It's all the same. We had it last time. Now we just have to pop in the battery and see if our code worked. So take the battery, we pop it in. And oh, you should look at that. It worked. Great. That's what we wanted, right? So the pin 13 is definitely that pin. It's right underneath these wires here. You can see that the LED is in fact definitely blinking on and off. In fact, let me pin it that way so it's not like blinding us as bad. It's turning on and off. Camera doesn't pick it up that great, but such is life. When you are a hobbyist teacher, just try to get some information out there and you don't have the best equipment, that's fine. It works. So we're going to use this standalone in future projects because it's cheaper than buying multiple boards, and sometimes you want to keep something you built if it's really cool and not have to spend, I don't know what, $10 now? I don't know how much these cost anymore off Amazon. It's easier to buy one of these chips, which cost, I think, like 50 cents. I could be wrong. I don't know. It's going to change over the years, so it doesn't really matter. But it's much cheaper to buy this than it is to buy a board. It's much cheaper to build this than it is to buy a board. Anyways, here was my great tutorial on how to build a standalone Arduino circuit and the basics to programming your own. You can upload any code. The only thing you have to look on is this diagram and match up the pins. It's a little tricky, but not that bad, right? So you can match up these pins to where they actually go on the circuit.